Over $150,000 can easily be the annual spend of just the VPC endpoints in your AWS ecosystem. What if I told you it doesn't even require a grandiose AWS implementation to get to the starting number? I should also add that I've not even included the data processing charge of endpoints. More to come on that. Welcome to PlatformCon, and thank you for attending this session on evading exorbitant expense of endpoints. I'm Atif Siddiqui, Senior Principal Software Engineer at Silicon Valley Bank, division of First Citizens Bank. This talk has been broken into 4 sections. We will start by going back in time. Don't worry, it will not be a 30-year trip down the memory lane. Since we're dealing with cloud, we'll only go back a decade. Next segment will be on the types of VPC endpoints, followed by the architecture to address the problem statement of runaway cost. I will close out with some of the key considerations in the design. Going back to 2014, if there was a requirement to access S3 bucket from a VPC resource, let's say an EC2, it would require the VPC to have an outbound, aka egress path. In a simplistic design, the VPC would need to have an internet gateway attached to it. This would allow EC2 a network path to get to the public endpoint of the S3 service. In the summer of 2015, AWS came out with a new VPC capability called Gateway Endpoint. It was released for S3 service and ensured that traffic to S3 endpoint remained on the AWS backbone. Equally importantly, it eliminated the requirement for VPC to have Internet Gateway attached to it. One of the key limitations of Gateway Endpoint was that it was only accessible from the VPC resources where this Gateway Endpoint was provisioned. To elaborate, this means the endpoint could not be accessed from on-prem or other peer VPCs. On the upside, the endpoint was free with no strings attached. Therefore, it was a no-brainer to create this gateway endpoint for every VPC being provisioned. Once the gateway endpoint is provisioned, the only thing left to do is add a route. This route associates the S3's AWS managed prefix list to the gateway endpoint. Considering how simple this design is from the customer's standpoint, I have never been able to figure out why it took another 2 years for the next gateway endpoint to be released. It was for the NoSQL database DynamoDB in 2017. What was also not known at the time that it was not only the second but actually the last gateway endpoint that AWS would release. The reason is because less than 3 months later, AWS announced a brand new capability called Private Link. This networking construct catered to multiple use cases while guaranteeing traffic remains on AWS backbone. Example, connecting VPC resources or even on-prem to AWS services. Another use case was for AWS SaaS partners to provide highly available offerings to its customers. Private Link is unidirectional because it can only be initiated by the consumer to communicate with the provider. As part of this Private Link release, a new VPC endpoint of type interface was announced. This endpoint was powered by the underlying Private Link networking construct. There were a total of 5 VPC endpoints announced. The list included EC2, load balancer, among others. Unlike gateway endpoints that are free, interface endpoints have a price tag. Pricing has 2 dimensions: data processing cost, which starts at 3/10 of a cent per gigabyte. The other dimension, and the conspicuous focus of this talk, is the hourly cost of 1 cent per network interface or ENI. For the sake of completion, let me briefly talk about Gateway Load Balancer, aka GWLB. This is a special type of load balancer that is put in front of third-party appliances such as firewalls, intrusion detection, or intrusion preventative devices. However, since GWLB has such a niche purpose, its endpoints can be safely considered negligible from a billing standpoint. Coming back to my $150,000 claim at the start, this is how one can easily get to it. First row is simply the cost of a single ENI. Since endpoints should be deployed across multiple availability zones for high availability, the second row shows the cost of endpoint deployed across three availability zones. What if every VPC of the count being vended had 8 standard endpoints deployed? It's actually quite easy to get to 8 considering the foundational services such as KMS, SNS, STS, logs, etc. In that case, the hourly cost rises to nearly quarter an hour. Scale to 50 VPCs and cost becomes eye-popping. We have reached $100,000 barrier for the annual bill. That is just a terrible look on the consumption model. Clearly, cost being directly proportional to the number of VPC provisioned is an increasingly expensive problem over time. The solution to prevent cost being directly proportional to the number of AWS accounts being vended is by centralizing VPC endpoints. Every application account, instead of having endpoints within it, should share these centralized endpoints. In the proposed architecture, endpoints are centralized as shown in the middle of the slide under Shared Service Account, boxed in blue. While this depiction advocates for a new dedicated shared service account, this could easily be incorporated into an existing shared service account of the landing zone. This slide shows two different application accounts outlined in pink. Both these accounts are relying on endpoints in the shared service account to get to AWS services such as RDS, backup, CloudWatch logs, etc. The subnets that host the endpoints in shared service account needs to be well thought out. At a minimum, subnet size should be /26, which will give 59 usable IPs. A reminder that each ENI of the VPC endpoint consumes an IP. In addition, for high availability, each endpoint should be deployed across 3, if not more, availability zones. I'm going to skip over the transit gateway networking because the connectivity of VPCs follows a very standard configuration utilizing the transit gateway route tables. I will, however, explore the private hosted zones and the DNS topic because I think it is one of the most interesting aspects of the design. The DNS resolution of VPC endpoints has to occur cross VPCs. It is important to note that these private hosted zones being created in shared services account needs to be associated with the VPCs of application accounts as depicted by the orange connectors. When the endpoint is being provisioned, private DNS feature has to be turned off. This is because the goal is to have the ability to resolve DNS names from the different VPCs of the application accounts. Let us try to better understand the private DNS feature. When it is enabled, AWS creates an invisible private hosted zone in the customer account. The existence of this invisible zone can be proven by the attempt to manually create a private hosted zone. Let's say for the name sns.useast1.amazonaws.com. Now in this case, because I have SNS endpoint already provisioned, the private hosted zone exists. That is why when I attempt to create it manually, I encountered the error in red, top of the picture. As part of the proposed design, for every endpoint being created, a corresponding private hosted zone has to be created for cross-VPC DNS resolution. A reminder that hosted zone is a regional construct. Therefore, in a multi-region setup, private hosted zone for both primary and secondary region has to be created for each VPC endpoint. Once the VPC private hosted zone is provisioned, an alias record needs to be created where the value is the fully qualified domain name of, in this case, the STS endpoint. I want to go back and highlight a third dimension of the cost that is now part of the equation. Since design requires traffic traversing over a transit gateway, data processing fee of transit gateway is now the third dimension. It should be noted that this third dimension remains dwarfed by having eliminated the multiplier of the hourly cost of the interface endpoints. Let me briefly touch upon the security group rules as the adjustments are quite intuitive. Normally, when an interface endpoint is created, the inbound rule can be safely set to the CIDR of the VPC. If connectivity from on-prem is also required, then on-prem IP ranges can be appended to the security group rule. Now, in this case of the proposed design, IP range needs to be extended to the supernet from which the application VPCs are being carved out. Then, in that case, the security group of the endpoints will allow all the application VPCs traffic to come in. The cost savings from implementing this design become increasingly significant as more and more accounts are vended. In my opinion, when an AWS landing zone is being set up as part of the foundational rollout, setting up centralized endpoints should be in scope. It will enable from the onset that the well-architected, prescriptive, multi-account AWS environment is not only scalable and secure, but it is also fiscally responsible.